Okay, we have a Kenmore clothes dryer here, and there's no heat. It runs, but there's no heat. So here's the schematic, and I just want to bring your attention to the 240 volt circuit, which, as you can see up here, 240 is up here, and the components that we're going to need to check are really all on this line right here. They all related to the heating element, which is right here. So, assuming the timer switch is closing, we have a thermal cutoff right here, and here we have an actual the thermostat, and then there's a high limit thermostat. So really, there's basically three components that we'll be checking with an ohm meter with the power off to determine why we aren't getting heat on this dryer. Okay, so we have to take the back off. It's a 1/4 inch nut driver, and there's 1, 2, 3, 4, 5, 6, 7. Looks like there's 7 on this one, so we'll take those off so we can get at the circuit. Yeah. Okay, first we're going to check this thermal cutoff on the 220 line here, marked FH1, FH3. That component is actually up here. What we're looking for is a low ohm reading. Show my meter if you could. Okay, 0.6, that's good. Next one in line is a thermostat. This should also be low, HT1, HT3. That's down here. That reads low, that's good. Now there's a high limit thermostat, HS1, HS3, that's down here. So we're checking that one, that's low. They're all good, so that leaves the heating element, H1, H2, which is down here. And lo and behold, it's open. So we've got a bad heating element on this dryer. Now that we know what the problem is, we have to unplug everything that's plugged into this housing, heating coil housing, up on top. There. And this over protector here comes out, and then of course the heating element itself. If you want to mark these, that's fine, otherwise they are labeled. And they are also easy to follow on the schematic. And just to make sure I don't do anything dumb, I'll just throw a little sticker on here. Marked heater. So there's no confusion between these two lower ones. Okay, so next we want to remove, with a 1/4 inch nut driver or socket, this mains cover, the electrical mains cover, because it's going to give us access to where we can get at a bracket that's holding the top of this housing here. There's a bracket up in here, so you can put a screw right up here and to 5/16. I'm getting at it with a 1/4 inch drive socket and ratchet, or 5/16 I should say. So with this little bracket out, the 5/16 inch screw, we can now tug this housing, give it a good jerk, and lift up on it at the bottom. It rests on those two little arms here, little holders, and we have it out. The only thing remaining to do then is to take out this screw. It's also a 5/16 sheet metal screw holding that. Slide out the heating element. And as we look it over, we notice that it opened up right here. The heating coils opened up. Okay, I have the replacement part here. Just want to point out a couple things. This time I made sure I got a factory service part, FSP. It's a Whirlpool, genuine Whirlpool part. Last time I did this job, just only 18 months ago, I did not. I thought I got the factory part, but I did not. And now as I look at these, you might even be able to tell here in the video, but the coils are there's more coils from end to end on the Whirlpool part, 30 versus 28 from end to end, and also these coils on here are thinner. They're just slightly less gauge. I measured it at 0.08 of an inch, so it isn't much, but it's enough. You figure the shorter coils and thinner results in shorter service life. So try to get FSP, factory service parts, from Whirlpool if at all possible on this job, unless you enjoy doing it. I want to do it again in about less than a couple of years. And it's a good opportunity to clean out the heater housing, which I did. This lint inevitably gets in there. Slide our replacement element in. Put our 5/16 sheet metal screw in there. Okay, now we'll go put it in. Okay, one little trick I found with this bracket is to just slip it in here ahead of time, and then just use a vice grip like this, pliers, little needle nose, just to hold it in place. It'll give you a little help. Okay, so we'll get it seated. Remember, it's got to sit. Got to rest down here in these two brackets. Okay, we're in. When it's in all the way, then it'll match up here, and you can push it. Basically. Just presses in there. So with the help of our pliers, we're able to get our little hidden screw up on top of this housing started. Okay, we're in. Alright, we're in then, and the housing is secured. So now it's just a matter of reattaching the wiring. These wires have no polarity at all. These components are all just like little switches, so it doesn't really matter which lead goes where. Now I'll get this other one. Protective device over temperature. And finally, here's our heater. Again, no polarity whatsoever. Okay, these are fitting a little too loosely, so with my pliers, I'm kind of crimping them down a little bit. I want a little bit better fit than that. If it's loose in there, it's going to create a high resistance connection, which will tend to overheat, and we don't need that. Okay, so we're all wired back up. Our electrical mains cover is going back on. What I'm going to do now is just test it, make sure it's going to heat up. Okay, looks like it's a glow in here. Now we're back in business. So I'm just going to put the back on. I'm not going to show you that. So, but thanks for watching. See the self-service call. So let's do some parts, and then we're back to the drawing business. Thanks for watching.